So we're going to talk about single and double buffer options, and the rest of the from here about to pretty much the end is really about um, planning and technical thoughts about this. And so while you may not be involved in actually implementing this, if you are in that space of marketing, you might want to think about the different user experiences that these different technical choices result in. And in particular, as I'll point out, you have to make some of these decisions quite early on in your product development as to how you're going to go. So, common theme of all these different these examples that I gave you is that one or two stages of bootloader starts up, selects some kind of an image and runs it. So the variations at this point are how the images are stored and how many choices you have in doing this. So and that's the effects of the recovery. And if you can't recover usefully, then the risk of a software update going bad is quite high, and your reluctance to update is quite high. And the users, if they ever experience that kind of a problem and have to return their device, is quite high. And so you get into this is where we get into the anxiety about doing updates. Is going to work afterwards. And in particular, if users won't update, then security patches can't be deployed. So we end up with a problem of all. So the key thing is the bootloader is sophisticated enough to roll back on failure. And either you have multiple copies so that you can roll back, or you're able to download an older copy when you do roll back. So this is what we call single or double buffer options. The question is, you have one copy of the system or two or more copies of the system. So if you go for a single buffered solution where you have one copy, the major reason why this happens is that the majority of your flash can be for application code. So that reduces your cost and your system requirements, lets you have a bigger, more sophisticated system on a cheaper platform. And it actually works well with in-place updates. So if you're mostly doing in-place updates without a reboot or a restart, then you may think, well, I don't need two copies. I'm just going to patch it in place and everything will work well, you think. It is very easy to retrofit. So if you have deployed devices which don't actually support uh, uh, double buffering, or you haven't planned for this well, then some kind of an in-place update is probably your only choice, and you should do this. The downside of this is that it potentially requires the smartest kind of bootloader. It might need to be able to get on the network using whatever network authentications there are, and it might need to be able to download a second copy of the firmware. So it needs a copy of the networking code. So whatever networking code you've thought to develop might need to be part of your bootloader, and that may be a serious cost of complexity in the bootloader and in your system. And it's probably more complicated for the users to recover because they have to do something potentially to get back into that bootloader and tell it that they really want to go back to what's going on. And certainly technical people and anyone who's dealt with phones or IoT devices, um, in the 2000s, has probably dealt with such a thing. And it's as technical users, it's often very frustrating to use this. So, okay, so you go for a double buffer solution. So the major advantage is your bootloader is significantly simplified. It doesn't need any networking code because it's basically just looking at, what do I run, image one or image two, which one is the latest one, or which one was the one that worked more recently, and that's where the logic is, which one is workable. Um, you can download the new image using your application networking code, and it can happen potentially while the application is running. And so it can happen. You can download it when network bandwidth is available, um, and you can avoid the stampeding herd of elephants where everyone tries to upgrade at the same time. And then you can reboot at the time when it's convenient for the user, such as if it's a door lock, I would say when the door is physically open and the device is the user is potentially maybe right there present, right? The downside is you probably only get to use 45% of your flash for your application code because you need another 45% for the second copy of the application code and maybe 10% for the bootloader. So it costs more. Um, and certainly 10, 15 years ago, the sizes of flash on system on chips and things like this was relatively small compared to what people wanted to do with them. Um, this year, most of the microcontrollers have often several hundred megabytes of flash at this point. And while they don't have terabytes of space, um, they usually have enough that this is much less of an issue today than it was before. Um, and you have to also ask yourself, what is the long-term cost of that, of avoiding a lot of complexity of the system? It certainly keeps your device in the field for a lot longer. One of the things I've considered is, for instance, you start with a double buffered solution, and as your application grows and gets more sophisticated, at some point it passes that 45% mark, and you make the decision that, oh, I'm going to go to a single buffered solution, and because my application is growing. And that's something a decision you could potentially make at some point about that. Um, but it's a decision you would have. One of the things about having two copies is that you have to decide if I'm going to execute them in place, if the code is position independent, meaning it can run at different addresses, or one possibility is that you actually compile the code for slot A and slot B at position dependent addresses, and you just happen to have two copies and you download one or the other depending on what goes on. Or you could have a fairly primitive MMU that allows you to remap the address spaces without actually really using it. Or maybe you actually copy the code to RAM anyway, you uncompress it, you decrypt it or something anyway. So it really doesn't matter. But I think the most important decision issue here is that something you have to actually make before you commit to a particular component. You have to decide what you're doing. And if you want to change your mind, you may have to switch to different components. And this could be quite a costly decision to make later on. Um, but it's something that I don't think can be left to just the procurement manager deciding what's going on. I think that it has to go all the way up into the marketing and user experience discussion as to whether this is worth them, what's worth the money. So how does this happen? How does the whole process go on? Well, the scenario that I've experienced and envisioned in many places is the software workers and the developers, they do software builds and they compile and then they sign their image with a development key. The development key can be run uh, by a bootloader. That's the orange signature there. Can be run by the loaded by development machines, which happen to have the R&D key. So the R&D machines will run production code, but they'll also run developer code, and they test it. And when everything looks good, they hand it to quality control. Quality control compiles it again and signs it with a perhaps a QA key or the actual production key, and they run it through quality control validation to see if it's okay. If it is, then that's great. They ship it. It goes out to a content distribution network, um, maybe with the same signature, maybe with the production one, and it's out there on the content distribution network, waiting to be loaded by the devices. The device downloads it. It puts it in Flash in some way or other, whether it's single buffered or double buffered is determined. And then it verifies the signature, and it needs to also in particular verify that it's got the correct firmware for the correct model on the correct system. Um, as an example of the why that really seems like, well, that's crazy, what would be the issue? Well, it turns out for my dishwasher, which has an MCU but it's not internet enabled, turns out there are 5 different control boards with 5 different system on a chips on it. And the reason I couldn't fix the dishwasher is because no one actually knows which one is which, because there's no labels on the device. And so in fact I had to replace the entire dishwasher. I'm very frustrated. But what would happen if it was just a firmware update and they had made that same kind of confusion? Well, I would be running code for an ARM processor, and I'd be running it on a MIPS processor, and it wouldn't work at all. So one of the ways that this can operate is the bootloader can come up. The bootloader can validate the signature again before running the code, and then it may just execute it in place. Okay, so that means it doesn't copy it out of the flash into RAM. It just runs it right where it is. A concern that people have with this process, although it is very secure and very good way to do things, is that the validation could take too much time. Um, and the question is it okay if the device boots in 700 milliseconds instead of 100 milliseconds? Is that an issue? Um, and how long does it take, and how fast are things? And so that's a consideration you need to think about with that process. The other way that this can work is the bootloader runs and executes the code. It doesn't bother to validate whether it's correct or not, because it assumes that the previous step, the purple box, has validated the signature and that everything's good. And if you need to boot really fast, then that may be the answer to do that. And there's variations in between these two processes where you actually re-sign the code with a local key and other things like that. But effectively, there is a trade-off as to whether you wanted to validate the code every time in some way, or whether you're just going to trust that whatever's in the device is okay. So how does the download happen? So the most obvious way is the device reaches out to the network and downloads it, and the user's essentially not involved. And I use a refrigerator here, and there are refrigerators out there with big LCD displays on the front of them that they can easily communicate and with the user and confirm it's a good time to reboot. And anyway, maybe it doesn't affect the cooling of the refrigerator anyway, so it doesn't matter. Reboot when you like. Another way is that the app downloads the from the from the internet, from the cloud, and then the app speaks to the device and uploads the firmware through Wi-Fi, essentially. Um, this may require that it requires probably that the user be involved, that their phone be nearby, and it may actually require that they click through some buttons. And this may be a good thing because they are now very aware that they're upgrading their refrigerator or their front door lock or whatever it is that they're doing. Um, and it also relieves the refrigerator from ever speaking to the network, and it certainly involves the um, relieves the refrigerator from actually having to have any kind of contact that way. It's probably better for privacy. But of course, you need to make sure that that step two is properly authenticated. And that's a potential issue um, if you don't do that right. Um, HTTP is not the only option. You could do a Bluetooth transfer. That's probably very useful and pretty much the common way for many wearable devices, which mostly interface via Bluetooth. None of the devices I have that I wear on my person for um, academic. I want to say academic. No, I mean athletic type things. None of them have ever come with a software update, to my frustration. But I would presume if they ever did, that's how it would work. I'm hoping to see one for my heart rate monitor, but so far not. Of course, you could be more old school. You could, for instance, download it to a PC, put it on a USB key, and plug the USB key in. And if it's a smartish device that doesn't really talk to the internet, it's just smart in some way. That's actually a really not a terrible way. It doesn't have to have a network stack. You plug the USB key in, it says, oh, there's a USB key here. It's some additional storage. It's essentially more flash. And it says, okay, I'll if that code checks out, I'll run that code and and it will be good. And you can even do something like you can even boot from the USB key and everything looks right. If it looks okay and the user likes the new software, then you store it locally. So it's not a terrible thing, but it does take a rather technical user that understands how to download something to a USB key. This is exactly what I expect to have happen if and when I ever get a smart furnace. I expect that my maintenance guy who comes in August when the furnace is not running to clean it would do exactly this, that they would have the USB key with the firmware for all the different furnaces on it, and they would upgrade it at least every year. And that would be part of my maintenance agreement. So far, my furnace has digital logic in it, but I have avoided the Wi-Fi interface because I haven't seen them with the upgrades yet at this point. But I think this is a really good model for big appliances that do have service people involved. So configuration, backup, restore, and preservation. So um, remember at the beginning of this talk, I wrote that your files will be right where you left them. This was about a desktop situation, and IoT devices. You don't usually think of them as having files, but actually they have configuration. And one of the most annoying parts of annoying bits of configuration that they have is your Wi-Fi home password if it does Wi-Fi. It was probably really difficult for you to get it into the device at this point. There are onboarding solutions, and we talked about some of that on the Tuesday's talk. If you want to go back to that, that can make it easier. But for the device that had 3 buttons and required that you scroll through the alphabet in order to be able to enter the password, that's something you just never ever want to do again. So that's something that you really want to configure. You want to preserve across upgrades. Um, and for some devices where everything is in the cloud and you may have a management station that does everything, as Hannah suggested, the Azure or Amazon kind of environment, um, that actually works really well. I mean, you just put the configuration in the cloud. You could completely wipe the device, new factory firmware, download the new configuration. Everything's good as long as you got network, right? You got to have network first for that to work. Um, One of the considerations is, where people don't always think about this as well. What if I replace the device? Because, in the case of my dishwasher, what if there had been an upgrade possible and it did have Wi-Fi? Um, Afterwards, I would like my settings on the new board. The old one just blew up, right? And I would like the repair person to replace that board and then be able to get my new configuration on the new device. So I actually want them to be able to transfer my configuration from one device to another. Wow. Okay. So then also I want my configuration backed up in a secure way that no one can see it. Ideally only can be decrypted with the device. But then I asked you, can you move it from one device that died to one device that's alive? So there's a fair bit of thinking that you need to do about what is the configuration and how does it work. And um, maybe you do want to store it on the person's smartphone. Maybe you do want to somehow back it up to the cloud, but maybe you want to think about how do I allow it to be decrypted and who can decrypt it, and there. Um, One of the things that does happen, and the next slide here, um, is that if this is a device that has any sophistication, there's probably configuration options that the user will discover that don't really work. And so now they're on the phone with support and they say, when I turn on the Frobber and then I allow it to go, at full speed, it stops and fails. And because no one's tried that option before. And so one of the things the technician will probably ask them to do after they, of course, ask them to turn it off and on, is they'll ask them to factory reset it because they want to know if the device is broken because it's got some hardware issue, or is it broken because it chose a configuration that just no one's thought about, just causes a fault or just doesn't make any sense. So they go into factory reset and, oh, it looks all great. And now the user says, well, how do I get my settings back? Right? Because I personalized it. And if that involves them typing them all in again, they're going to be really unhappy. And if it worked last week and then there was a software update and now it doesn't work this week, and that's why they're on the phone, well, it's not their fault for picking wrong devices. It's the software update's fault. And in most cases, the users will say, I'm never upgrading again. Well, that's it. So now you have a problem of you have devices out there that users are hostile to updating, and you want to ship a security fix, and they don't want to install it. So that's an issue, and that's where the configuration matters. If you let them back up the configuration and restore it, then that's a good thing. So, for example, in the enterprise and the ISP space and the Cisco routers and other things like this, when you factory reset it, it actually doesn't delete the configuration. It just runs the factory configuration. And if you, once you've made sure the device is okay and everything's okay, then you say, oh, I'll just restore the configuration from the backup. And then you go along your merry way. And if the device fails again with the configuration that you saved, then you know it's something wrong with your configuration at least. I think that's almost the last slide. So that's what I really just talked about. Unusual configurations. And the other interesting part about this, of course, is they can send you their configuration. The user could say, well, this is my configuration. I'll send it to you. It's in some format that you can deal with. You can reproduce in the lab, and you go, oh, wow. Yeah. It turns out you shouldn't put your step counter in flight mode when you go on a train because it gets confused, something like that. And another set of questions is the last bit of questions, if there's anything else.
Please do ask any further questions that you might have at this stage. We have about 10 more minutes left, so there's definitely time to have further discussion. Michael, while we're waiting for questions, why don't you run through your sort of final thoughts on this, and maybe then we can pick up some of the themes in the last few minutes.
So I think of the software updates as when they work well, they're just beautiful. Everything's just great, and then they don't work well. It's a major failure. Probably many of you saw this picture of SpaceX landing their twin boosters simultaneously last year, or maybe it's 2018 now. I can't remember. And it was just amazing. And that's clearly the photo of the decade of these two things going. And they go, that's rocket science. Well, it wasn't just rocket science. It simply was good planning. And you got to actually wonder, what does SpaceX do for software updates? And do they ever do software updates, while a spacecraft is in space? It's an interesting question. I would assume not. But in the end, this is about planning. It doesn't have to require genius. It's simply, you have to think about what you're going to do, and you have to think about the fact that the updates are not a a problem you need to work around. It's actually a feature. One of the things that we talked about in developing this presentation was the extent to which the software updates, the process, and uh, getting it working well early on in your development process means that you can leverage it. It might actually mean that you can ship alpha products out to the field, which when you haven't actually finished the application yet, because you actually know, well, I can just update easily, and that's a feature. Lets me get to market faster.